This problem asks us the amount of time that has to elapse before a certain amount of cesium decays down to a much smaller amount. Let's go ahead and write down the numbers. We're talking about cesium-37, so we'll go ahead and write that down right here, this isotope. It tells me that the half-life, or T sub 1/2, in this case is equal to 30 years, so we'll go ahead and write down 30 years here. It wants us to begin with 25 milligrams, so that's the amount of cesium that we're starting out with, and it's asking us how much time would have to elapse until this is decayed down to 8.7 milligrams. What are these amounts? Well, these amounts are actually equal to n sub 0, that's the amount that you have at time equals 0, and it's n sub t, that's the amount that you have at time equals t, in this case t being t being, well, some amount of time. We don't know what that is. So there's an equation that I gave you guys in the video that says that the natural log of n sub t over n sub 0 is equal to a negative kt. The t is what we're trying to find out. So once again, it wants to, we're trying to figure out how much time has elapsed in order for 25 milligrams to decay down to 8.7 milligrams. N sub 0, n sub t, I can plug those right into that equation. The big trick right here is the k. How to figure out what k is? Well, there's a separate equation that I also gave you in the lecture video that says that k is equal to 0.693 divided by the half-life of the substance in question, or T sub 1/2. At least I think that's the equation. Yes, it is. So I can go ahead and put 0.693 divided by 30 years because it gives me that as the half-life. So the final answer to that ends up coming out to be 0.0231 per year. So inverse years, that's the units for k. So this is k. So I'll write down k. I've got n sub 0 right here. I've got n sub t. I can plug these numbers right in to their relative positions. I can take this value for k, plug it right into there, and solve for t. When you do that, unit-wise, you should end up getting t in years, and that really is the final answer. So once you have these values, it's pretty much just a plug and chug problem. So I'll let you go ahead and do that on your own.